Hello everyone, I'm Vidya and today I'm going to walk you through the significance of Fermat's theorem. The first significance is that Fermat's theorem can be used for primality testing. Now what is primality testing? It means that using Fermat's theorem we can check whether given number is a prime number. Okay, so how can you do that? Let us say we have two integers. Let us call it as a and p, and a is not divisible by p. Then if these numbers satisfy the condition a raised to the power of p minus 1 mod p is equal to 1. So if this condition is satisfied, immediately you can conclude that p is prime, because this particular condition will be satisfied only and only if p is a prime number. If the condition is not satisfied, it concludes that p is not a prime number. Therefore, you can use Fermat's theorem to check whether a number p is prime or not. So the next significance of Fermat's theorem is it allows you to do faster computation of modular exponentiation. So I shall explain this with the help of an example. Let me say I want to compute 2 raised to power of 1000 mod 13. So one way of doing it is to use a traditional method. So I have discussed the traditional method in detail in one of my videos. The title of the video is Computation of Modular Exponentiation. However, what we do in traditional method is that we first check out what is 2 raised to power of 1 mod 13, then 2 raised to 2 mod 13. Then we check out what is the value of 2 raised to 4 mod 13. Then we proceed with 2 raised to 8 mod 13. 2 raised to 16 mod 13, 2 raised to 32 mod 13, 2 raised to 64 mod 13, 2 raised to power of 128 mod 13, and likewise we compute the final answer, which is 2 raised to 1000 mod 13. So if you do this method, this becomes quite a lengthy method. You have to compute each and every values here. While if you use Fermat's theorem, you can directly skip these many steps and compute 2 raised to power of 13 mod 13. So if I have to compute 2 raised to 13 mod 13, that is a raised to power of p mod p, where p is a prime number and a is not divisible by p, it is congruent to a. So you can replace the answer by a. So this answer directly you know, without solving all these steps, you directly know that 2 raised to power of 13 mod 13 is 2. So using alternate Fermat's theorem, I've skipped these 4 steps and directly jumped to 2 raised to 13 mod 13. From Fermat's theorem, since we know 2 raised to power of 13 mod 13 is equal to 2. Now if I square this number, that is 2 raised to 13 into 2 raised to 13 mod 13. That is, we are squaring the right hand side also, that is 2 into 2. So we get the answer 2 raised to 26 mod 13 is equal to 4. So you must have seen that you have skipped certain steps and have directly reached to some intermediate answer of the traditional method, and this makes the computation faster. The next significance of Fermat's theorem is to test if number a and p are relatively prime. Since Fermat's theorem satisfies the condition a raised to p minus 1 mod p is equal to 1. It indicates that a and p are not divisible, while a and p have their greatest common divisor as 1. And since it satisfies this condition, these two numbers are relatively prime number. So if this condition is satisfied, that is p is a prime number, and if this condition is satisfied, it indicates that a and p are not divisible by any number. That is, the only number with which a and p are divisible is 1. And since the only number with which a and p are divisible is 1, the GCD of A and P is 1, they are relatively prime numbers. So you can see guys, Fermat's theorem has got so many features, and because of all these features, Fermat's theorem is used in a number of cryptographic applications, in a number of encryption algorithms, wherever you need to test if a number is prime, when you want to test if A and P are relatively prime, or if you want to do your modular computation faster, we can use Fermat's theorem. So guys, I hope all of you understood the concepts clearly. So with this, we come to an end of this video. Check out my next video. So thank you guys. Stay healthy, stay happy, stay blessed, and see you all in my next video.